It's now time to continue our discussion of factory method operators in the Flux class. If you recall, before we talked about some of the basic ones like from, we had one that was from iterable. There's a bunch of different ones, just. Those are some ones we talked about before. Now it's time to turn our attention to the one parameter version of create. There's several different versions of create. And we're going to see this is used to create a Flux stream that does not have flow control enabled, does not support back pressure. So here's what create looks like. It creates a flux that can emit a bunch of elements, either synchronously or asynchronously. That's quite fascinating. We'll talk about that more later. That cross-cuts with the discussion we just had about schedulers and concurrency operators. The parameters that are emitted by what's passed as the emitter parameter, which is a consumer that's parameterized by something called a flux sync, will emit any number of next signals followed by 0 or more error or complete signals. So these are the things that are emitted in this context, and you'll see how that works. Create supports much more dynamic and, in many cases, much more concurrent or asynchronous use cases than just the flux, just, from iterable, and from array operators. Those are very simple. If you recall, they were very eager, and so create is lazy and much more dynamic. It returns a flux that emits all the elements generated by the flux sync. So this is the flux sync parameter, and it gives you back a flux that will have everything emitted by that. Let's take a look at an example. So here is a method called generate, which we're going to write just for kicks. So we have a method called generate. We're going to give it a supplier and a count. And what the generate method is going to do is it's going to call flux create to synchronously generate count instances of whatever is returned by supplier.get. So as you can see here, we have a lambda expression that gets passed in as the parameter to create. And this little lambda expression is basically a little program into itself. And it's going to iterate for I equals 0, I less than count. And it's going to increment by 1 each time. And it's going to call supplier.get. And it's going to emit that by calling sync next. So the next method will then emit that up to the flux that's returned by generate. And this keeps going for I equals 1 to n. And when we're done, we say sync.complete. Now, just a quick note, we haven't really talked about this yet. We haven't talked about the range operator. No self-respecting reactive programmer would ever use a for loop like this, an index-based for loop. It's like so, 2005 or something like that, so old school. They would use flux.range, but I haven't talked about that yet, so we're doing it the old school way for right now. So what's happening is we're going to generate count of these values that are whatever supplier.get is going to return. And then when we're done, we say sync complete, which is kind of like end of file. Everything's finished. The one parameter version of create does not support back pressure. And therefore, it can emit a potentially endless stream of elements at whatever rate the publisher is running at, as fast as it wants. As you can see back over here, it's going to do it really fast. It's going to emit them just as quickly as that for loop can execute. There's no delays, no nothing. Therefore, one of the downsides with this is that a fast publisher can easily overwhelm the memory and processing resources of a slower consumer or consumers. And here's the famous I Love Lucy video, which if you haven't watched it, even though it's like way old school, you should take a look. It's pretty funny. Lucy and her friend are working in a chocolate factory. I think it's chocolate, maybe it's pies. Looks like chocolate. And they can't keep up with the rate at which the pies are coming down the conveyor belt or the chocolate's coming down the conveyor belt. And so they start like stuffing it into their clothes and stuffing it into their mouths, trying to keep up. And of course, eventually it overwhelms them because it's just going too fast. So that's what happens. That's a good example of fast publishers overwhelming the resources of slower consumers. Fortunately, there's two solutions we'll talk about shortly. We've sort of hinted at this earlier. You can either use the 2-parameter version of create, where you can give an overflow, a strategy for handling things where the suppliers generate data too fast, a back pressure strategy, or you can have back pressure aware publishers and subscribers. Either one is a way to solve this problem, which we'll talk about later. Elements can be emitted from one or more threads. You can have one thread doing this, you can have a pool of threads doing this. Depends on what you're trying to do and what other forces are constraining your design. Are you trying to read data from multiple different places and you want to do it in parallel so you can speed things up? It all depends on what you need to do. RxJava has a create method that's similar. It's called flowable create. Observable doesn't support backpressure, but flowable does, except they use different data types, again, for mysterious reasons. Java Streams also has a method called generate, and you can give it essentially a supplier lambda that will generate a stream of whatever, and it'll do it forever unless you put some kind of a limit on it. This is an example where we're generating a stream of random, large, and unreduced big fractions, but it really could be whatever we want to do. So that's the end of the overview of the create operator. Very, very powerful operator in either its 1 or 2 parameter versions. We'll talk about the 2 parameter version here shortly.